gold. And when you think about the fact that this soil probably took hundreds of years to form,
Hello, my name is Christine Brown. I'm a field crop sustainability specialist.
it's Monday, it's March, and we're back with March Manure Mondays, our final episode for 2026. Thank you for joining us, and on behalf of Christine Brown and myself, Andrew Barry, with the Ontario Ministry of Agriculture, Food and Agribusiness, we'd like to welcome you back here. So we had a good session last week. If you joined or watched the recording, manure safety. Wow, there was some incredible stories and facts about safety, and a powerful video as well that was shown with an aerated dragline hose and what happens when that busts free. So encourage you to check out that recording along with the other three from weeks 1, 2, and 3. We've been getting lots of good views, and I trust that you'll enjoy the information that is there. So, quick logistics again. Our usual, we'll go till 3 o'clock. Session is recorded and will be posted after on OMAFRA's Field Crop News YouTube channel. This is accredited as one Certified Crop Advisor credit today for nutrient management. And it also is, if you're part of the OFCAF program in Ontario, a knowledge sharing event or a KSE. So we will have that QR code at the end. And I will say that if you are a part of that program, you're a farmer and you've got a pending OFCAF project, you will need to click on that to submit your claim and to submit that form. On the call today, we have Hannah George from OSCIA. So if that does apply to you and you have questions, you can reach out directly to Hannah. All right, today's topic, our final topic, is organic amendments and contaminants. And I'll invite the presenters here to just give a wave as we get started. There's going to be a good panel today, great panel of presenters, and I'll introduce them. Scott Mabury is going to kick us off. Scott is from U of T, and then we have Ryan Prosser, who is from the University of Guelph, and then Phil Sidwa, who will be on cleanup, and he's maybe had a few years experience in the biosolids industry that he can draw on from the industry side. So we're going to let all three go and give a bit of a commentary, and then we'll come together as a panel and we'll invite your questions as we have a discussion. With that, Scott, we're going to turn it over to you to get things started, and off we go. Organic amendments and contaminants.
Thanks, Andrew. Scott Mayberry. I'm here from the University of Toronto. I'm going to show a couple of slides real quick just to frame it a little bit. I have a farm in Northumberland County, a couple of them, owned and rented. You can see the rotations there, mostly no-till, cover crops, soils, old tobacco land, so you can see some evidence of that. Have applied lots of manure, compost, biosolids, paper solids, but my day job is as a professor of environmental chemistry at the University of Toronto. Today we're talking about PFAS, perfluoral or polyfluoral alkyl substances. I'm giving a couple of structures here. I gave a longer talk at this with Chris at SWAC a couple of years ago. PFAS stands for perfluorooctane sulfonic acid, is one of the ones that CFIA regulates in amendments, biosolids, etc. The limit is 50 parts per billion, very specific number. I'll talk a little bit more about that. It's interesting because this is in your blood at probably about 15 micrograms per liter, 15 parts per billion. So just to give you an idea, the CFIA limit's at 50, but you have North American population between 10 and 30, probably average. We can also find, it's interesting, other PFAS in human blood and of course in biosolids. This DIPAPS food contact paper used on fast food containers, pizza boxes. I had microwave popcorn last night, probably got a decent dose. These things we also find in humans as well. And in fact, there's an analogous cousin of this structure that probably is the number one source back in the day of PFAS contamination. So I've published a couple hundred papers on PFAS. And in my world as a professor, numbers of papers and how often they get cited is sort of our metric. I may have more papers in this domain than pretty much anybody else, but I wanted it just sort of as a joke. There's my obligatory July 1st corn picture. 2024, of course, because 2025 not so good given how dry it was. But I wanted to give you a bit of a metric. I manage a couple hundred bushels of corn per acre, maybe a slightly more, but the equivalent in the research world is more about 450 bushels of corn. So I have a couple hundred, 250 papers or so, but in my world, that makes me a very good corn farmer, but not so much out here. The reason I'm on here is that I've had biosolids applied and all the other things on my ground for the last 15 years or so. You can see a pretty nice cover crop after a biosolid application here. Bring it in from Coburg as liquid or as pellets. And this delivery here and this nighttime delivery actually were part of an experiment that Ryan and I are doing, funded from OMAFRA. And that experiment is asking the question, how much PFAS is coming in via biosolids to a farm? What PFAS are there? How much does it add to the burden of existing PFAS in the soil? And I'll explain that in a little bit. Do those PFAS move into the crop, and can you find them actually in the fruiting part of the crop, the corn grains, soybean grains, et cetera, wheat, et cetera? So one of the things that my research in this space, because I've been really interested in these things since 1988 when I started my PhD work at the University of California, Davis, on fluorine and how it influences the fate of pesticides. More than half of all pesticides and pharmaceuticals contain fluorine. It's a very powerful member of the periodic table. Its unique properties is why it's used so much. But we've learned that actually rainwater has quite a bit of PFAS in it. It has that one of those structures on the last slide, the PFOS itself. This structure here is in rainwater at measurable concentrations, as well as many other compounds. So we've published papers of how those get into rainwater, what the reactions are that produce those, the concentrations. We've published papers, soil sampling from around the world, including Antarctica. PFAS is measured in every soil sample we look at because it's delivered atmospherically from volatile chemicals, PFAS that evaporated and that Mother Nature degrades into the final products that EPA and CFIA are regulating. So the first thing to recognize, and is left out of almost every single newspaper article about biosolids and PFAS, is that there is a background concentration and it's coming from the atmosphere. Thus far, we can measure PFAS in those biosolids. I've applied them between 3 to 4 tons per acre, which is a little higher than sometimes. I think 1 to 2 is more typical. We cannot measure a significant difference in the soil before and after application of the biosolids. Now, my biosolids have all come from non-industrial sources. They're primarily human derived. And if you hadn't thought about this, the PFAS and biosolids are primarily coming from us. When you go into the toilet and flush, they're basically emitted through our own excretion into the sewage treatment plant system and then get processed. Now, a lot of what we secrete sometimes are these other chemicals that then degrade in the sewage treatment plant or later in the soil into the compounds regulated. One of the issues of why biosolids have become somewhat controversial in the New York Times articles and the others were based out of a biosolid issue in Maine. That particular issue, those biosolids came from an industrial paper mill that was a source for coating of food contact paper chemicals, in particular, more paper plates and those kinds of things. There's a world of difference between that kind of source material for biosolids and normal residential kind of source for those biosolids. So that's one of the things that we're exploring, and one of the things that I think for the continued access of this material for benefiting agriculture, which I believe it does, we need to be able to discern the differences. So that over to you, Ryan. I'm going to stop sharing.
Thanks,
Try to
Scott.
stop.
I'm not as long in the tooth as Scott is, but I've still had uh, lots of experience in my relatively short career when it comes to contaminants in biosolids. So even my PhD, when I started out, well, first of all, I'm a faculty member at the University of Guelph in the School of Environmental Sciences. My area of research is environmental toxicology, which is sort of a fancy term for trying to understand the impact of contaminants or chemicals in the environment. In my research group, we work on soil organisms, which would be definitely relevant here, but we also work on freshwater species and then more recently on marine species. But all of it revolves around understanding the impact of these contaminants on these different species. But working with biosolids and soil amendments goes back to when I did my PhD. I did work here at the University of Guelph, looking at the uptake of pharmaceuticals or personal care products up into crops and the effects of those things on crops from from biosolid amendment. And then, so then I was a postdoc at Environment Canada, and now I'm back at the University of Guelph. And the work Scott mentioned that we've been doing recently, funded through OMAFRA, again looking at the concentrations of these PFAS molecules in biosolids here in Ontario, on fields in Ontario that have been amended with biosolids, and then also on fields that haven't been amended. And like Scott mentioned, trying to understand, are there significant differences between fields that are or are not receiving biosolids? Um, and part of another element of the work that I'm doing is looking at biota from those fields. So we've been looking at earthworms. Earthworms, again, everybody knows they're important for soil health, but they also act as perfect little living samplers. I mean, they're cruising through these fields. They're coming in contact with a lot of soil, and so we look at the concentrations of PFASs in these worms from fields that, again, have been amended with biosolids and fields that have not. And again, trying to understand, are there significant differences in those worms? I mean, they're living in that soil, they're eating that soil. Are there significant differences? In general, what we found from these fields in Ontario that are receiving biosolids from municipalities in Ontario, we haven't seen significant differences in the types of PFASs that we're seeing in the worms and concentrations. And this sort of relates back to what Scott was saying, in that we're not really seeing significant differences in the soil. And that's also, again, we're not seeing significant differences in the worms that are living and eating that soil. One part of the project will also involve looking at crops that have been grown in these fields. So corn, soybean, wheat. We've sampled these crops from these fields, and so right now I can't share with you what we found yet, but we're busy working on those samples to look at if there's a difference in the PFAS molecules that are in the crops from amended fields and unamended fields. And that's important for the public and for farmers, right? I mean, a lot of these crops are being used to feed livestock or going into human food. And so, that big question, and it goes back to our biosolids contributing PFASs to the fields, which is then causing elevated levels in the crop. So the data will be interesting. I mean, our hypothesis is that they're not significantly different based on we're not seeing significant differences in the soil. So why would they be significantly different in the crops? But it's an important question that needs to be answered. The other part of my research is looking at these concentrations, like Scott mentioned, in fields that are amended or not amended, we're finding these perfluorinated chemicals, polyfluorinated chemicals. Are they at levels that would cause effects on soil invertebrates, things living in the soil, on soil microbial communities, which are really important for soil health? So that's another element of our research. And so far, what we found is that the levels that you would require for perfluorinated chemicals to have adverse effects on things like earthworms or on microbial communities are considerably higher than what we're measuring on fields in Ontario that are receiving biosolids. Now, that's not to say, like Scott mentioned, that they couldn't get to levels that are high enough to cause adverse effects if you're not doing source control, right, to those wastewater treatment plants. If you're not careful about what's going into your wastewater treatment plant, and you have industrial inputs that are causing levels of PFAS off the charts, obviously if you're applying that to your field, that could be a problem. But here in Ontario, what we found from testing biosolids at various types of biosolids for municipalities, and then the fields that are receiving those biosolids, is that we haven't seen levels that would constitute a considerable risk to the invertebrates or the microbial community that's living in that soil, and by extension to the crops that are being grown on those fields. A year and a half of it, there's still more work to be done, but what we've found so far, again, for here in Ontario and the farms we were working on, we haven't seen levels that we would consider a risk that needs to be addressed. And then another area of research that might be of interest to people too is that my group has also been working on microplastics. So that's another kind of classic contaminants that people are increasingly more concerned about is microplastics. I mean, I'm sure you've all heard about you know, um, these newspaper articles about microplastics in our blood and that sort of thing. An interesting fact that I like to share is that we all eat about a credit card a year in terms of microplastics, which is funny to think about. They come from wastewater treatment plants. So, do they contain microplastics? And then is the microplastic content of farmers' fields higher in fields that receive biosolids relative to fields that don't? And so that's another area of research. And then again, do these microplastics, are they at levels in fields that would constitute a concern in terms of soil health or health of earthworms or health of crops and that sort of thing? And again, a number of our papers are out there, but the gist is that the microplastic content that we're seeing in fields, and again, microplastics in a way are kind of like PFASs, right? There's a lot of different sources. Biosolids by far are not the only source. There's aerial deposition of microplastics. They get blown in the air, and there's breakdown of larger pieces of plastic. But anyway, the gist that we're finding is that, of course, we're finding them in fields like we're finding them elsewhere in the world, but they're not at levels at this point where we would see that they would cause adverse effects on soil health or plant growth or earthworms. Now, the issue with microplastics is that level could continue to rise as we as a society continue to produce more plastic. We're very bad at recycling the plastic we have. And so that's one of the other concerns is that, well, would this level continue to go up because plastic takes a long time to break down? I mean, depending on the type of plastic. And so again, this doesn't negate that we've got a plastic addiction that our society needs to sort of address. We need to get better at recycling because right now, I would say from the biosolid and the field perspective, it's not a risk, but it doesn't mean it's not something that we need to address upstream. But anyway, so that's a little bit about my research and what we've been doing. Again, the microplastic, there's still a lot of work to be done. We continue to do research to try to understand the impact of these contaminants on particularly agri-ecosystems. And I think I'll stop there and let Phil take over.
Thanks, Ryan. It seems my wife consumes a lot more than one credit card worth of microplastics. I'm humbled to follow the excellent presentations by Scott and Ryan, and thank the folks at OMAFA for having me on board. My name is Phil Sidwa. I'm chair of the Ontario Biosolids Council and would like to talk today about the work we do on the council. As a bit of background, over the past 40 years, I've been involved in the biosolids and wastewater treatment business through consulting and operating companies that I've run. And as a bit of perspective, I sat on the original sludge guidelines committee, as they were called then, back in the 90s, together with Professor Tom Bates from Guelph and John Slyhoff and others. And over the years, having traveled around the world, working for the United Nations in delivering teaching courses on biosolids around the world, I can tell you one thing, that Ontario's nutrient management regulations are amongst the strictest in the world. And I can also tell you that over the past 40 years of us having used biosolids in Ontario, there has never been an adverse effect to the health of humans, animals, or crops when the proper regulations are followed. So we are truly the global gold standard of environmental protection and legislation, with so many safeguards around the handling of biosolids in Ontario. So just quickly, biosolids are the treated organic solids that come out of a wastewater treatment plant that has been provincially licensed to treat wastewater. So the Ontario Biosolids Council was formed about 2 years ago, and it was established by select industry and municipal partners to maintain land application as a beneficial and agriculturally sustainable option for biosolids recycling. There's been increased public pressure and misinformation that's been going on out there. And so our efforts are focused around the agricultural sustainability and stewardship of demonstrating the benefits of biosolids, which are, of course, rich in organic matter and fertilizer for the crops and our soils, along with the added benefits of carbon sequestration and our efforts in fighting climate change by not incinerating or having to landfill these important organic materials. We're primarily concerned about PFAS and other contaminants and their potential to create further barriers to land application. Let's not forget, biosolids aren't the problem, but remain an easy target. It's the upstream dischargers into the wastewater treatment plants that need to be regulated and controlled in terms of what is being dumped into our sewer system. Recently, as Scott mentioned, there were issues in Maine, Connecticut, many of the Northeast states, and Quebec over the imports of biosolids and the banning of these biosolids based on knee-jerk reactions by public activists and politicians who did not fully understand the issues, but decided to pass legislation without scientific backup. And so they put moratoriums on land application in Maine. And what ended up happening is because the landfills and incinerators were no longer able to handle the material out in the northeastern US, material started coming into Quebec. And so this prompted us to revisit our legislations and regulations here in Canada and then in Quebec and in Ontario. At the OBC, the Ontario Biosolids Council, we worked very closely with the regulators. So we worked very closely with CFIA, the Canadian Food Inspection Agency, together with OMAFA and MECP to create proper legislations, regulations, best management practices around the use of these substances. CFIA came up with a limit of 50 parts per billion for PFAS in biosolids. And in Ontario, our wastewater treatment plants are very easily able to maintain that and meet those regulations. We work very closely with the MECP and OMAFA. We have regular meetings with the state of Michigan, as well as with other organizations like the Northeastern Biosolids Residuals Association, the Water Environment Association of Ontario, to make sure that we're all informed of what's going on in this world. So last year, the Ministry of Environment sampled 20 wastewater systems in Ontario, and the concentrations of the PFAS in all the samples were well below the Canadian food inspection limit of 50 parts per billion, with almost all results below 20 parts per billion. Most of the time, the results were below 10 parts per billion. So we have a good safety margin in there. These concentrations are considered to be low and similar to those measured in other Canadian and U.S. jurisdictions where there are no major industrial discharges occurring of PFAS into our sewer system. Let me just note that 1 part per billion is 1 drop of water in an Olympic-sized swimming pool, or 1 second in 32 years. That's a part per billion. So we support current research at the University of Guelph and Toronto that Scott and Ryan alluded to, and we monitor research going on globally to ensure that any regulations that we impose in Canada or in the province are based on sound science and not knee-jerk reactions that are politically motivated. So we want to make sure that science is at the forefront of any new legislation. From a public relations and education point of view, we engage with public activist groups. I've spoken to many. I've written articles in the Ontario Farmer magazine and other places to talk about the benefits of biosolids. We have a very progressive quarterly meeting with the state of Michigan, which has come a long way in turning all of the quality of their biosolids around. It's very interesting in Michigan, as an example, they had the electroplating shops, paper mills that were dumping material into the sewer system, causing high concentrations of PFAS. And through proper legislation, through proper methods of working with these industry, they brought the levels right down to the extent that there has been no impact in agriculture. Farmers still want the material, and municipalities haven't slowed down generating all of this. There are small-scale solutions being developed. However, it's very difficult to create solutions to treat these materials at a large-scale wastewater treatment plant just based on the size of these plants. So you have smaller-scale carbon filters that can be used in your house, etc. But again, what do you do with these filters? They end up going back into a landfill, and the leachate comes back into the wastewater treatment plant. So it's a cycle that we have to stop at the source, and the source is the industry and us using it that are dumping it into the sewage system. Just to end, to give you an actual scale of what biosolids mean to the agricultural community and to municipalities, as we do with everything in life, we need to look at the risk-reward balance to weigh the many benefits of these organic amendments. Biosolids provide huge amounts of nitrogen, phosphorus, organic matter, even zinc and copper, which are important amendments and micronutrients to you in your agriculture. When we look at the cost savings that farmers get out of biosolids are valued at about $400 to $500 an acre, and that's not with the current global situation, such as the wars that are going on, that will see the fertilizer prices continue to rise. In Ontario, we produce about 1.2 million wet tons of dewatered biosolids, which is about 12 million cubic meters of liquid, depending on what units you use.
Yeah.
65% of materials are land applied, 30% are incinerated, and 3% are 5% are landfilled. So the cost to municipalities to stop land application and go to landfills and incineration would be tremendous, and there are no real landfills and incinerations around that could take it. So anyway, in conclusion, the recycling of organic amendments on agricultural lands makes a lot of sense from an agricultural, environmental, and a public perspective. Best solution is to stop using it, stop discharging it into our systems, and maybe changing our lifestyle. So that's all I have to say for now.
Very good. Thanks, Phil, Scott, and Ryan. So I'll invite you guys to come on in with me on a panel, and I will shoot the breeze together on this. I will say right up front, I like the fact that all of you guys are very practical. So, Scott, I know you wish you had your John Deere hat on today, but we do know you are a farmer. We've seen the pictures and seen the research. Ryan, we just need to look at your office to know you're a practical guy, and Phil with all your years of experience. So it's important to bring this down. There's a lot of technical and research aspect to this, but it does affect us in a practical way. Ryan, I'm going to start with you first of all. Just like one of the questions that comes up. So this stuff, you found it in Antarctica, you found it all over. It's in people. But does it bioaccumulate? And is that something that's a real concern, particularly in soil biota and
Mm.
others?
Yeah. No, that's a great question. I mean, and again, I think there's still a lot of work being done. But what we've found, so bioaccumulate means, like, I mean, just to quickly, is that it would build up in the tissues of an organism, right? And what we found is that with a lot of the organisms we work with, is that, I mean, of course, they're going to consume it, but it ends up just being, coming out the other end. I mean, we all ingest things that aren't, are inert or not providing nutrition, right? Like microplastics. I forget how much dirt the average person consumes over the course of a year. Toddlers a lot
Peck of
more.
dirt before you die, right? Isn't that it?
Yeah, or something like, yeah. And but so our bodies as well as the other organisms, I mean, they've been, evolved in order to sort of extract out the nutritious stuff, and now the other stuff goes out the other end. And so that's what we've seen with, things like earthworms. Of course, they'll ingest microplastics, but then they just egest them. And so they're not building up in their tissues, right? So they go in one end, they're out the other end. Plants, there's still work to be done. For plants, for example, the microplastics have to be small enough to actually be transported up into the plant, right? I mean, probably through the xylem, through that but for the majority of microplastics, there's no way that they would be taken up into the crop because they're too large. So there's still a lot of work to be done there. But for the most part, for most of the species we've worked on, it's kind of whatever goes in then comes out, like any other waste product that's not providing nutrition to the plant.
So, Andrew,
Microplastics.
yeah, on the PFAS things, we know very well what chemical architecture is required for bioaccumulation, bioconcentration. And in fact, we published a paper with a PhD from University of Guelph, John Martin, who was in my group, and then did a postdoc. We published a paper specifically looking at the chemical architecture and what's required for bioaccumulation or bioconcentration. We know it requires 7 carbons with fluorine, and then either a sulfonate or a carboxylic acid group. And that's why all of industry in the early aughts shifted to 4-carbon chemistry. Prior to that, most things were 8 carbon. PFOA, perfluorooctane, sulfonate, octane is the name for 8. All of industry shifted to shorter chains, in essence, for a greener outcome. Now, some people would take exception to that comment, but the fact of the matter is the products of those do not bioaccumulate or bioconcentrate. So a significant effort was made to have a better chemical architecture, a greener architecture, in order to avoid bioconcentration. Now, most PFAS do not bioaccumulate. Most are either too large or too small. All the pharmaceuticals and all the agrochemicals are not particularly bioaccumulative because of the fluorine, for instance. Prozac or trifluralin or Sidwa was my new favorite herbicide.
Yeah.
These things are not bioaccumulative in the way we tend to think about them. Now, the problem is regulators are thinking about banning all PFAS, anything with more than two fluorines on a carbon or three fluorines on a carbon. That would capture most of the pesticides, most of the pharmaceuticals, and frankly is a sledgehammer to a smaller problem. We need, as Phil said, we just simply need to be far.
Mm. And just carry on, Scott, because in the chat, Mark, who is a swine farmer, asks, and I think we know the answer, but just confirming, are livestock also a source to the manure?
We have yet to measure an environmental sample that we cannot measure PFAS in. That's more a comment on our exquisite, powerful abilities to measure very small amounts of things. Yes, any manure sample. So Christine Brown has sent us a bunch of manure samples. We've find PFAS in all of them, but at extremely low concentrations. So well below regulatory limits. They
Good.
get there because they're ubiquitous. I mean, any pig or cattle or sheep out grazing is going to pick up some from that's coming out down in rainwater and finding their way into forage, for instance. But probably some of the additional products applied, we find it in fish food, small quantities. But pretty much if I can find it in every person on this call, and it's very easy to measure in everybody here. It's just a measure of how widespread these compounds are. None of the concentrations in typical humans are cause for adverse health effects. Industrial exposures, that's a different matter primarily, but the average person is not facing harm from those concentrations to the extent that I'm aware.
And Mark continues with a question here that I'll just read to you, okay? And whoever can jump in and answer. He said, we use a soil amendment from Strathcona Paper Company from their recycling program. They bring in paper fibers and recycle them. The product that Mark gets is the fines that are too small for them to recycle into their paper products, which they collect, windrow compost before delivering them to the farm, applying a high PFAS product in this case. He said the product itself sure works great, blended with hog manure for building organic matter in the soil. But again, the question is, would that be a high PFAS product? Okay, are you able to say that, Ryan? Any thoughts, or Scott? Do you know?
Well, I had paper biosolids from a recycled plant in Oshawa. So that's different than what Mark is talking about. Recycled paper fibers have significant quantities of PFAS. We published a very nice paper. The soil processes into the final degradation products. Again, even in that situation where I was putting on quite a bit of tonnage per acre, and it was partly for an experiment to follow these PFAS, there are measurable quantities, yes. Now, I don't know, the Strathcona paper, is this when they're making the original paper before any coatings go on? And if that's the case, then I wouldn't expect much at all. But I agree, it's a wonderful soil amendment.
Yeah, right on.
My suggestion would be that Mark goes back to Strathcona and asks them to do some sampling of their materials. There is no real threat to them right now because the 50 parts per billion CFIA regulation only applies to biosolids. Now, if it turns out that they're at toxic levels by Canadian standards, then that's a different story. But it's always nice to do your due diligence as a generator of any material to go and get it tested and keep it as background information.
Phil, one of the things just want to reiterate that you expressed, and that is just the fact that when we're talking about biosolids and calling them an organic amendment, is the assumption, or it's more than an assumption. The fact is that it has to be a benefit to soil. Like we're not talking about dumping waste products. Just so everyone's clear, who's watching this, we're talking about treated biosolids. We're talking about a treated product that is measured, and we're talking about a benefit to soil. And I think that's really important. Any comments on that, Phil?
Yeah, that's absolutely right. So any organic amendment that we apply, whether it's from an anaerobic digester at a wastewater treatment plant or from an organics processing facility, has to meet certain criteria. So the criteria that the ministry establishes are in the processing and treatment of the material. So you have to reduce it to a certain bacterial count. You have to have so many days of retention time within the digester to make sure that it's a safe material coming out. Once you take that material out, all of these organic amendments can only go on licensed field as non-agricultural source materials. So they're either NASMs or products licensed under CFIA. Most of the materials we generate in Ontario still go out as NASM materials. And so each field, each site that accepts it has to go through an entire farm evaluation. There's a professional agrologist that get involved in licensing the farm, and we get a license from the Ministry of Agriculture and Food that allows us to apply those specific biosolids from that specific treatment plant on that specific field based on soil pH, distances to groundwater, bedrock, wells, etc. So it's a highly controlled program that ensures that only the best materials are getting out there under the strictest safeguard.
Now, that's so absolutely. We're all on page for that. At the same time, realizing we have a public relations challenge because there's concern. There's concern about these products. Nobody's saying there's zero risk and there's no concern, but like we're doing the science to measure and to evaluate and monitor over time. Robert mentions in the chat some of the horror stories that Michigan farmers and others have had to deal with, and those are very real, but they're isolated situations that I think can be traced back to point source, frankly, as much as anything. So, but the public relations challenge, what do you want to comment on that, Scott, for starters?
Happy to. That Michigan story, we just have better data to be smarter. The Michigan cases are almost all electroplating emissions from electroplating factories and units. I've seen the data from Michigan. I participated at a public meeting and presentation there where they were identified and source reduction at those locations, then the impact of the biosolids on the receiving stream was dramatic, and those biosolids could continue to be used. It's where they are unknown, significant loss and emissions out the in pipe. That's a significant problem. We do have a challenge because there is a view, there are a few tens of thousands of PFAS, many, half the pharmaceuticals, half the agrochemicals that would be caught up in a ban. We need to be smarter. We need to demand that industry produce better chemical architectures. I use that phrase because how you put the atoms together directly influence what their fate in the environment is, whether they're a problem or whether they're not. We published a couple of papers on my own group. There are PFAS that will work where we want them to. They'll repel water, repel oil. Those are the two primary things having these fluorinated compounds do. And yet, when they're released into nature, she's able to degrade them all the way back to their starting materials. Fluoride, for example, completely an issue. That's the pressure we need to bring, the great human creative spirit to solve these problems, build better architectures. I think that's a better way to go. In part, we have to recognize there is a challenge. There are situations where biosolids are going to be heavily contaminated and they need to go to one of the other destinations versus a field. But I will state unequivocally, carbon fluorine, that bond is unique in nature. It's unique. It's not replaceable. There's sometimes replacements, but they're never quite as good. And what that carbon fluorine bond does in pharmaceuticals and agrochemicals, replace chlorinated compounds. And we all know that chlorinated compounds were a different problem. And so we don't want to throw the baby out with the bathwater, as some people sometimes say.
Andrew, just on the public relations side, we have to learn in our industry to be a lot more transparent and open with the public. So we need to be able to communicate openly at forums. Before we apply biosolids on any site in Ontario, we go and talk to the neighbors, tell them what's going on, give them pamphlets, OMAFA, MECP literature, and make sure that they understand exactly what's going on. So you don't want to build up those animosities and hostilities right off the start. Go and tell them we're here to work with you. And then you get into the science and the research side. I'm just seeing a comment here about the 300 tons to the acre is what it would take for that field. So in Ontario, from the city of Toronto, for example, we apply biosolids at 10 tons to the acre. That's pretty much the maximum you'll apply out of any treatment plant in in Ontario is 10 to 12 wet tons per acre at about 30% total solids. So when we start looking at these numbers of 4,000 pounds of nitrogen and it's like way out of whack. Yeah.
Yeah. Yeah, and I'm I do take comfort as well knowing MECP, which is in Ontario, that's the Ministry of Environment, Conservation and Parks, have been sampling. Do you know, Phil, are they going to continue to sample in years ahead? Or was
Yes,
that
absolutely.
okay?
No. So the pilot test was with the 20 wastewater treatment systems, and so those results have come out, and now they're going to be spreading their wings wider into other treatment plants and going right across Ontario.
And Ryan, do you know in the general sense, like are numbers decreasing, plateauing, increasing? Do we know what's happening, or is that on the agenda for future research?
Well, I mean, Scott will be able to, one of the things when it comes to biosolids, I think, is that we don't, in terms of a trend, right? You need a certain amount of data over a certain period of time, I think, to come up with a confident trend. And so I think with biosolids, I don't think we're necessarily there yet. I mean, I think the more intensive sampling has been starting to occur, especially since things kicked off in Maine, as we've mentioned. There's been a lot more work done. So I think over time we're going to get a better sense. I think it's gonna vary depending on the molecule, right? Like some of them, we might see declines, some we may see increases, right? Because they're, potentially replacements, that kind of thing. The one thing before I let Scott, because Scott will be able to speak to this, is I just want to mention too that, Environment and Climate Change Canada, right? Shirley Ann Smith has been doing a lot of work, her group, looking at wastewater and biosolids and PFA. So there's even outside of Ontario, more Canada-wide, there is data out there. It is on their radar, and it's something that they're looking at outside of Ontario and that sort of thing. So there's nationally, there's work being done as well. Well, let's Scott in terms of the trends and timelines, because he may be able to speak to other matrices in terms of rain or yeah.
So I put in the chat, basically over the past 25 years or so, 3M, the major producer of PFAS, have declined in humans by about 75%, or probably over 75%. So part of that was the big change from 8 carbon chemistry to 4 carbon chemistry, or 4 to 6 carbon chemistry, as I mentioned earlier. But also industry was sloppier 25 years ago. They've learned, and of course they're learning the hard way in the courts by losing a bunch of billion-dollar cases. They're billion-plus-dollar cases. And so they've gotten a lot better at, as to Phil said, recognizing there's a problem, reducing into the pipe emissions. But frankly, most of the compounds found in humans and elsewhere now are not directly from the plants. They're from the in-use products that are cycling around. And so we still have some work to do to create greener projects.
Yeah, I want to read this question. This is a wonderful question from Jacob, posted in the chat. And then, Phil, I'm going to let you start and give everybody a chance to answer it. But here's his question. What tips would you advise a crop producer on how to establish a relationship with a biosolid supplier that would minimize the risk of getting high concentrations in their inputs?
Yeah, sure. So the first thing you need to do, and I'm speaking as an operator of TerraTech Environmental back in my day, which was Canada's largest biosolids company, which we founded back in 1988 and then sold in 1999. But anyway, I'm still engaged today, and so what you want to do is go to the producer of the biosolids, so the wastewater treatment plant that is in your area, that is sort of within a 30-kilometer radius of your agricultural land. 30 kilometers, we can push to 40, is about the limits of where it makes sense from a transportation logistics point of view to take materials. I can also give you the contrary viewpoint. From the city of Toronto, we haul materials 120 kilometers away to take materials out of the city, obviously, because you've got a very small rural environment there. So you need to find out from the wastewater treatment plant what its analysis of materials looks like. So you can go and get these analysis from them if they're in fact doing any PFAS testing. Remember, it's not legislated as yet to do PFAS testing for NASM materials. For CFIA product materials, which have gone through additional treatment like lime stabilizing or pelletizing, you have to have a PFAS analysis done every 6 months. Okay, so depending on the type of material that your biosolids contractor is handling, there may or may not be a legislative requirement to perform that test. If there is, then the plant will show it to you, and you'd be seeing how much PFAS there is in there. It will be in parts per billion. If it's a NASM material, which is not further treated, then there are no limits to it, no established regulations to it. Does that partially
Scott,
answer?
yeah, that's great. Scott, you want to add?
I can't add anything. Phil
Okay, Ryan,
answered it
anything to add?
perfectly.
No, I was gonna say Phil covered it because I would say just to add to that is like just being upfront, right? Asking the right questions and just seeing what those producers where they're at, because I think like as Phil and I know, there's some very progressive municipalities, and I think I mean majority of the ones that we've worked with in Ontario are on top of this, and they want to produce a good product, so. Yeah, I think just asking, those questions and it also puts on the producer's radar, what questions are important to farmers or, to people receiving those amendments. And so, yeah, I think dialogue is probably a really good place to start asking those questions, voicing concerns, and yeah.
Awesome. Great answer, Phil, as well. And I think you answered Mark's question already. Scott, I'm going to ask you, put your farmer hat on. So you obviously believe in biosolids. You're applying them on your farm. You've been continuing to. Yeah, nicer pictures come from the 2024 crop year, but 2025, dry year. Did you see any benefit to all those years of applying biosolids? I'm just curious.
Massive. So as I said earlier, I normally have about 5 tons corn per acre. Last year I got 140 bushels per acre. Everybody around me was under 100. Everybody around me was under 100. I mean next adjacent along the same highway, all old tobacco lands. There was a study Christine Brown and I did with compost a number of years back. I had a 23 bushel per acre benefit from compost, no compost. And it just all comes to water holding capacity was the primary. This is sandy soils. You saw the sandy loam, not loamy sandy for sure. So the benefit is real in that regard. And it certainly benefited me. I mean, the guys around me were getting 2 tons per acre of corn. And that's about as painful as it gets this year because we really didn't have anything like a no more year. So yes, I'm pretty sold on the benefit and focused on the advice Phil gave, staying away from industrial sources of PFAS that make it into the sewage treatment plant that would make it into biosolids. That's our worst problem in my view.
Fantastic. Listen, guys, we're at the end of our time here. So thank you to our panel for excellent information. That really appreciate each of you, Scott, Ryan, and Phil. That great job. And as we bring our series to a close, I will say that as participants, you will receive a survey from our contact center, just any feedback and more importantly, suggestions for next year, because we do plan to run this again next year. Also, don't forget the North American Manure Expo this year is in Nebraska at the end of July. And then we'll be hosting here in Ontario in 2027, August 10th to 12th at the Elora Research Station. So we'll look forward to seeing you in person then. But thank you so much to everyone for attending. Thank you to all our speakers for all 5 weeks. I want to thank in the background Quinn Harder. Quinn has been our technical host and has been doing the editing and posting of the videos. And we've worked with Quinn for 5 years, and we just really appreciate him. And of course, Christine Brown, who is the brains behind this operation. So thank you to Christine, and I always enjoy working together with you, Christine. Your feedback, suggestions are really welcome. I will end with a quote that Glenn Arnold said, And he said this in our week 1, and that was that people that value manure do a good job of managing manure. And that's what this series is all about, is valuing manure and managing it well. So thank you to everybody. Have a wonderful spring as we head there. Be safe and enjoy. Cheers.
Thank you.